been traveling around to a bunch of the Oracle Code events worldwide. We've done these across the US, Europe, and now Asia. We just finished Oracle Code Japan, which was an awesome event. We're on a motorcycle tour following that event, traveling across Japan, visiting different user groups. The reason why Oracle's reaching out to developers is the way people buy software, services, and products has really changed. Now developers have a lot more control over the technologies they use, so we want to directly engage with developers, teach them about some new open source technologies, and then show them that those technologies which we're using run very well on the Oracle Cloud. One of the big advantages Oracle has is having a very large community. So by building on top of our stack, you're not only getting the Oracle products and services which run on our cloud technology, but you're also getting a lot of community support from folks in those open source technology communities. So there's over 300 Java user groups globally, Java user groups and the Oracle user groups. They run their own events, they talk about technologies, they help folks get up to speed on how they can use our cloud technologies and platforms, and you can be part of the community. Basically, we're traveling across Japan and stopping at a dozen user groups in between via motorcycle, so it's a very efficient way to hit up a bunch of different communities throughout Japan. In the big cities, you get large numbers of developers because there's large consulting companies, a lot of software development happening there. But in the smaller areas of Japan, you get a very local flavor to the communities and the user groups, and there's large user group communities. But they don't always get the attention and the visibility which they would get normally if they were in a large hub like Tokyo. On this tour, we have Sebastian Daschner, who is a Java champion from Germany. He's presenting about cloud-native Java development. We have Kirk Pepperdine, who is a internationally known performance tuning guru. And lastly, we have David Delabase, who is a Java EE and WebLogic evangelist for Oracle. It's great that we share a common interest in motorcycling, and we're able to use that to spread a little bit of our passion about Java to the global user group. I've been traveling around to a bunch of the Oracle Code events worldwide. We've done these across the US, Europe, and now Asia. We just finished Oracle Code Japan, which was an awesome event. We're on a motorcycle tour following that event, traveling across Japan, visiting different user groups. The reason why Oracle's reaching out to developers is the way people buy software, services, and products has really changed. Now developers have a lot more control over the technologies they use, so we want to directly engage with developers, teach them about some new open source technologies, and then show them that those technologies which we're using run very well on the Oracle Cloud. One of the big advantages Oracle has is having a very large community. So by building on top of our stack, you're not only getting the Oracle products and services which run on our cloud technology, but you're also getting a lot of community support from folks in those open source technology communities. So there's over 300 Java user groups globally, Java user groups and the Oracle user groups. They run their own events, they talk about technologies, they help folks get up to speed on how they can use our cloud technologies and platforms, and you can be part of the community. Basically, we're traveling across Japan and stopping at a dozen user groups in between via motorcycle, so it's a very efficient way to hit up a bunch of different communities throughout Japan. In the big cities, you get large numbers of developers because there's large consulting companies, a lot of software development happening there. But in the smaller areas of Japan, you get a very local flavor to the communities and the user groups, and there's large user group communities. But they don't always get the attention and the visibility which they would get normally if they were in a large hub like Tokyo. On this tour, we have Sebastian Daschner, who is a Java champion from Germany. He's presenting about cloud-native Java development. We have Kirk Pepperdine, who is a internationally known performance tuning guru. And lastly, we have David Delabase, who is a Java EE and WebLogic evangelist for Oracle. It's great that we share a common interest in motorcycling, and we're able to use that to spread a little bit of our passion about Java to the global user group. I've been traveling around to a bunch of the Oracle Code events worldwide. We've done these across the US, Europe, and now Asia. We just finished Oracle Code Japan, which was an awesome event. We're on a motorcycle tour following that event, traveling across Japan, visiting different user groups. The reason why Oracle's reaching out to developers is the way people buy software, services, and products.
Developers build the future. We take ideas and make them real. My job is to think, create, and solve for a living.
Each step we take is possible because someone asked the questions. Why do we have to do it this way? What if we did it that way?
Each step I take enables people to go further.
Be creative, change something. I'm working on blockchain that will change asset identity.
Artificial intelligence to automate homes.
Autonomous robots to improve efficiency.
My app is advancing human rights.
I build things to help connect people. Not everyone gets to build their passion. We share what we know. We share what we do.
Try, learn, try again.
Make, break, build.
All right, so welcome everybody to the Oracle Code New York event. So you guys saw a little bit of the Japan tour, which we've done in previous years, but actually right now we have 6 of our advocates traveling around Japan, visiting different cities via motorcycle. And I'm going to be joining them after this conference. So we have some unconferences, we have user group events at a lot of unique places like Kumamoto, which it had an earthquake a few years ago. So we're going to be visiting them for the user group, going to Osaka, Nagoya, also went as far north as Sapporo. And this is a great way to reach a broader community of developers, specifically in Japan, but also we do this in India, Europe, and North America, and other cities as well. I think the next tour coming up is Latin America. So I'm going to talk a little bit about the technologies and stuff which you're going to be able to see today at Oracle Code New York. And we're going to discuss as an intro the journey from being a developer. How many folks in the audience here are developers? Okay, very good. You guys are in the right place. And everyone else who didn't raise their hands, hopefully by the end of the day today, you're going to feel like you can also raise your hand and say that you're a developer. And hopefully you'll also be able to say that you're a groundbreaker. And so the question is, what do you need to be a groundbreaker? What technologies, what new emerging trends are coming out? What things do you need to do with your career to improve and grow in different ways? And one of the ways and areas in which you can do this that's a very hot and trending technology is serverless technology. So with serverless, you don't need servers anymore, right? So this is not quite how serverless technology works. If anything, you're actually standing up more servers in cloud infrastructure in a shared hosting environment. But some of the benefits you get over traditional server architectures are you're only paying by the server time that you're using. So this gives you better economies of scale. This gives you the ability to use off-peak load time. You're building a micro-function architecture. So if you're already doing microservices or you're looking at ways which you can take your application architecture and break it down into even smaller chunks, serverless is the smallest possible chunk which you can build because you're literally deploying little functions out into the network, and you're only paying for the time that these functions take to execute or call other functions. And then you can automatically scale in a cloud environment using serverless technologies. So this gives you infinite flexibility depending upon the cloud provider you're using. And then the latency is relative to the distance between the end user and the closest cloud node which they'd be deploying on. So the ideal here is that rather than paying for a lot of upfront infrastructure costs like you would with traditional servers, you're simply paying by the utilization, and you're saving all of that, that magical green area there in the chart. Oracle has a great serverless technology, which is called the FN project, and it's entirely open source. So you guys can download this today, give it a try, and you can actually deploy it to your on-premise hardware, or you can take advantage of a cloud-hosted version of it. We have the new Oracle Cloud Functions coming out, which will let you run this on top of Oracle Cloud infrastructure. And we're also using this technology in one of the local experiences which you can try here at Oracle Code New York. So we have the code card. This is a small embedded device that has ESP8266 compatible chip on the back. It has Wi-Fi support in the chip. On the card, we have an e-ink screen that you can use for a display. We have a couple buttons you can use for interaction. And we have some instructions on how you can use the Oracle Cloud account, which we're giving you guys for free today, to then hook this up with some serverless functions and then have those return data back to the screen. So you can customize the code card and have it do different things when you push the buttons. So this is a great way you can play with serverless technology, connect that with your embedded expertise as well. And then we have code cards to give out to attendees who are interested to try out this experience in the Groundbreaker Hub. Okay, so now you've got your serverless. This is going to take you to new places, so it's kind of like a jetpack for superheroes. You can tell that this is my bad developer art. I actually drew most of these pictures on the way to the Oracle Code London event, which was the first event of this year. So this is my bad plain art. Next technology we're going to talk about is Kubernetes and containers. How many folks are already using container architectures in your daily work? Okay, so quite a few folks. If you haven't already started using Docker or Kubernetes, this really is the modern way of doing development. It makes your whole workflow from going to a local environment to deploying to production a lot more seamless. And if you think about the evolution of where this came from, so, you know, we used to do bare metal servers, so you just deploy things directly on the hardware. That's still the fastest way to get things running in terms of raw performance, but you lose a lot in terms of scalability, especially when you have a 64 or 128 core machine. You're unlikely to be able to properly exercise that hardware unless you have multiple applications deployed, which is how we came about with virtual machines. So this lets you have multiple operating systems deploy different applications in their own little sandbox operating system, but it means you have to have a host operating system with a hypervisor. There's more indirection. You're setting up and patching multiple operating systems on the environment, so it's harder to maintain and keep it going. And also, you have quite a lot of overhead. So where containers comes in is it removes a lot of that overhead. It gives a container runtime, which makes the applications believe they're isolated, but actually they're running all inside of one host operating system. And this gives you more performance, and it also makes it easier to maintain your applications by packaging them up and having simple packages which you can deploy via the container runtimes. You get multiple applications with their packages and all the things they need in nice little bundles. You can run on both your development and production servers. So there's a typical analogy to this where, you know, you talk about containers and docking and ships. So here's my little ship. So again, a great example of geek developer art. Who would ride on my ship? Anybody? All right, so we got some brave folks in the back. Unfortunately, this isn't the most seaworthy vessel. And what might happen in production is not going to be a love story. So what you'd like to have is you'd like to have some way of scaling out your architecture, making sure that you can actually deploy this across multiple machines easily. Kubernetes is a great technology for doing this. It allows you to control a farm of machines. This would allow you to have multiple ships. Each individually, they may not be as seaworthy as you'd like, but if one of them crashes and burns, then you have another machine to back it up again. We have this as a service running in Oracle Cloud, Oracle Kubernetes Engine, or Oracle, Oracle, I can't remember the full name for it, but anyway, OKE is our acronym internally. There it is, Container Engine for Kubernetes. That's the full name for it. We also have our cloud registry, container pipelines based on Worker. As I mentioned, the functions is coming soon, so that's in limited availability. We have Resource Manager, monitoring, notification, streaming, and a new event service coming out. So a lot of these services which you need to build modern application stacks are the foundation of what we've built with the new Oracle Cloud Infrastructure Stack. So now you have Kubernetes. This is like your utility belt for developers. So you're like Batman. You have a bunch of different tools at your disposal. The next technology which you might be interested in deploying is using digital assistants. They're usually not friendly robots like this, but they typically come in some sort of messenger form, like using Facebook Messenger, WeChat, Slack, or if you were in Japan. Actually, the first time I presented this was in Kumamoto. A lot of these slides were actually written on last year's motorcycle tour. And when I presented this to the local team, the local developers in Kumamoto, they pointed out that the most popular messaging platform in Asia is Line. Or you might be using a robot like this. So the Pepper robot's actually built by SoftBank Robotics, which is a Japanese company, although it's a French design. It's designed by Aldebaran, which is headquartered in Paris. And we actually have a Pepper robot here you guys can interact with. It's backed using our digital assistant service, so you can ask it questions. And this is a great way to interact directly with chatbot technology. So it's a great technology to incorporate in enterprise applications. This is the new user interface beyond web and mobile. And also, you can look into the future and then chat with a robot backed by a cloud blockchain service. Okay, so just like Iron Man has Jarvis to talk to, we have Pepper in our visor. And the next technology we're going to talk about to become a groundbreaker is blockchain technology. So blockchain is all the hype, probably more for the cryptocurrency than the underlying technology. Who has Bitcoins in the audience? Anybody? Okay, so you guys are buying beers for us? So probably last year you were incredibly rich. I think the value of blockchain or Bitcoin has dropped quite a bit since then. So you're probably not the millionaires you used to be a year ago. But the basic fundamental technology behind Bitcoin is something you can apply to your enterprise applications, which is blockchain. And the way it works is it's a large distributed ledger. As you add new transactions to the block, you hash them together using a Merkle tree. Then that's hashed together with the previous block, a nonce and a timestamp, and that becomes the new candidate block in the blockchain. In the case of public blockchain, your proof of work is via miners. For a private blockchain, you would have some other reconciliation strategy, like you might invite people into the network, you might have a consensus strategy or some other way of resolving it. The big advantage of using a private blockchain implementation is you're not constrained by the limitations of public blockchain, where you can actually have enterprise data that's private, you can use smart contracts to do more complicated business logic in the network, and you have faster transaction times. The transaction time in Bitcoin and Ethereum is quite slow, so 7 transactions per second or a 10-minute completion time for blockchain. Whereas if you were doing a private implementation, you'd really want faster microsecond transaction times for your network based on your business requirements. So there's a lot of industries where blockchain is really taking off. Financial services. We've done a supply chain use case as well at Oracle. That use case is the blockchain beer project, which we did together with Alpha Acid and unveiled at Oracle Code 1. Basically what we did is we worked with a local brewer called Alpha Acid, who's actually right across the street from the Oracle headquarter buildings. So they're a little microbrewery. They make great beer. They have really good ratings on Rate Beer, but also we instrumented their brewery with a bunch of IoT sensors that feed data back into the Oracle Cloud. We also worked with their suppliers. They have a local hop supplier, a local yeast supplier, and then a malting factory, which does traditional floor hop malts. And we got those incorporated into the Oracle Intelligent Track and Trace, which sits on Oracle blockchain technology. And all of that data is fed back into the cloud. You can get back a little mobile UI, which shows you where your beer is coming from. And I believe we also have this demo here for you guys to enjoy today as well. So check out this and the other demos we have in the Groundbreakers Hub. So now you have your blockchain, which this is kind of like a drone going out and collecting information. And the last one we have to talk about today is autonomous database. So autonomous database is a new technology which we've come out with recently, which applies the concepts of self-driving, self-securing, and self-repairing, just like you'd expect from a modern autonomous car, to your database. As a developer, this really eliminates a lot of the complexity. So how many folks who are developers here have ever set up Oracle database from scratch? Okay, a bunch of folks. Did you finish that in under a weekend? Maybe not. So give Oracle Autonomous Database a try. So the promise here is you should be able to set it up in an afternoon, probably in a few minutes, if everything goes smoothly. And it's a much quicker way to get up and running with Oracle Database. Automatically does patching, securing. We have a new feature coming out, which is really cool, where it will do automatically tune your database. So it will use machine learning algorithms to automatically figure out the, which tables need indexes, how it should do the scaling of the database for you. And theoretically, you just answer these 6 questions, and you're up and running with Autonomous Database in minutes. So Autonomous Database is kind of like your self-driving car. And then if you put this all together, then now you're a groundbreaker. So hopefully you guys will learn about these technologies today, and then you too can be a groundbreaker. Okay, so for the first presentation today, we have a really, really exciting speaker who I want to invite up, and a personal friend. Please, Venkat, come up to the stage. Thank you. Take it away.
Thank you very much. Well, it's a great pleasure to be here. Thanks, everyone, for joining us. I'm going to talk about what I want to see in languages of the future. And I'm going to show that to you by showing some of the languages. I'm a huge fan of programming languages. I program in about 15 different languages. And I like to really learn new languages. And what I'm saying in so many words is that I'm not good in any one of them. But I love learning about languages, and one of the reasons I love learning about languages is it makes me think very differently. It makes me apply the ideas very differently. And I want to share with you some of the thoughts I've been having about what I want to see in languages in general. Well, the first thing I want to talk about here is, you know, we often hear people say that things change really fast in the world of computers. And I want to think about how fast things actually change, and is it really true that things actually change so really fast? So from that point of view, I remember way back in time, decades ago, when I started programming. I've been programming for about, I'm going to say 30 to 35 years now. And I remember spending the time on VT100 terminals. You would be sitting there on what we call as DERM terminals. You would just type away, and that runs on a machine somewhere else, a mainframe computer. And then, of course, things have changed. We went all the way to personal computers. We have handheld devices. And now everything is running on some faraway machine on the cloud. Feels like we have a full circle we have come about in a way if you think about it. But a lot of things have changed over the past about 20 to 30 years. It's really nice to grow up in a field to see the changes that are happening around us. And this reminds me of one experience I had. I was visiting the store with my wife and my son. And as we were walking through the aisles, my wife pointed out to a whitener and said, and she kind of smiled and said, oh, look, there's a whitener right there. And my son immediately said, what's that for? And she said, oh, this is what people use to type on a typewriter, and then if you make a mistake, you use this to white it over so you can type it over it. My son is a very patient person, so he listened to it and he said, what's a typewriter? And I should have known to be quiet, but I was excited. I said, hey, did you know what a typewriter is? Daddy wrote all his thesis on a typewriter, but he didn't know typing. Your grandma actually typed Daddy's thesis. And he was even more fascinated that my entire thesis was written on a typewriter. And then he looked at me and said, and why would people do that? Why not just use a printer? And now I was trying to explain to him why people use typewriter. And that's when I realized I ran home before he could come home. and I went to my closet and I hid all my floppy disk, what would he think of if he ever finds out that daddy once used floppy drives? Well, things are changing so fast that there's a generation of kids growing up not even knowing what these technologies were for, and it's just fascinating. But then, of course, let's look at what happened in the past about 50 so years. A lot of things have changed over time. And I remember, I'm old, but not that old. I've had friends who have, used mainframe computers and punch cards. And I have a friend of mine who would be so eager to explain how there would be huge machines in rooms bigger than this, filled with machines that were really good at generating a lot of heat. And of course, today we have handheld devices, very small, that go in the pocket with more computing power than these machines of the past. But then I asked the question, what do we use these machines for? And I travel around the world. I spend a lot of time in airports and other offices, and I've come to a very firm conclusion. This is my analysis of what all these beautiful modern technology do for us. And I admire the human quest to create new powerful devices so human beings have options like never before to play solitaire. That's what people actually do these days. And this is amazing to have all this computing power on our hands. But the question is, what are we doing in terms of programming for these new modern devices, modern environment, big data, all of those things in cloud computer? How are we programming in the new century? And if you really look around, unfortunately though, what it amounts to pretty much is this. I remember, one day I was programming at my home, and my wife, who has, taken some computer science classes way back in time, she knows enough of programming to be dangerous about it. And one day she came around and looked at me coding, and she said, "Oh, Venkat, after all these 30 years, you're still programming C++. And I said, "No, this is not C++, this is Java." And then she came around to make things worse and looked at my code for a minute and said, "Okay," she said, "I'll give you this. You don't have delete, and that's pretty much it is. So this is all but C++ without delete." And I was not too happy hearing this, but to be fair though, that's true, isn't it? Because Java is mostly C++ without delete. And the point really is that we've been programming the modern world with languages and syntax we created decades ago. And how does that make us feel? Sometimes we wonder, is this going to give us the agility to move forward, and do we need some other tools and techniques to develop it? Well, sure enough, some things are really fundamental and really hard to change, and we got to give that. For example, almost every single language we use, worth the salt, is Turing complete, which is a good thing. That gives us confidence that we can use these general purpose languages to solve our problems, and that's very useful. And of course, we have to suffer through the von Neumann bottleneck. We are still going to deal with all these issues with pulling data from memory and other devices, and we have to still work with it. But at the same time, though, let's think about the languages and the world around us. When was object-oriented programming introduced? Let's think about that a little bit. Anyone wants to take a guess? What year was OOP introduced? Don't worry about being wrong. I'm wrong most of the time myself. 1967, 68. That's a correct number. So 1967, that's the year when the ideas of object-oriented programming was introduced by these two Norwegians, Dahl and Nygaard. The term object-oriented programming was coined by Alan Kay, but the ideas were introduced out of Norway, and Dahl and Nygaard introduced back in 1967. Does anyone remember the year object-oriented programming became mainstream, like nobody even questioned it and started using it? I'll give you a clue. It was after 1967. What was it? 1990, give or take. Now think about that for a minute. That is 23 years. If OOP was a human, it had a terrible neglected childhood. Nobody cared about it. And one day when it was 23, "Hey, handsome, do you want to hang out with me?" This is amazing. Why did it take 23 years for something to become really mainstream? Well, we'll think about that. We'll talk about that a little bit later. So this was introduced back in 67, really mainstream around 90, give or take a few years. But what about functional programming? Well, of course, we all get excited about functional programming now, But when was functional programming really introduced? But let's go a little further. Even beyond functional programming, let's talk about Lambda Calculus. Does anyone remember what year Lambda Calculus was introduced? Any guess? 1936. Well, Well, you're not actually too far. You're absolutely correct. Everyone here knows of Alan Turing. This was Alan Turing's Professor Alonzo Church introduced the concept of Lambda Calculus back in 1930s. Now, one last question. What year did functional programming become mainstream? Okay, that's a trick question. Not yet. A good 90 years later, we're just warming up. And so when people tell me that things change really fast in our field, I always ask them, what are you smoking? Because it doesn't change as fast as we think it does. It takes a very long time. And I don't think 25 years is a short time at all. And where do these numbers really come from? So it got me wondering, why do things take a few decades to change? What is the reason why things don't change so quickly? You know, what is the reason why the syntax of Java looks like C++? What's the reason why syntax of C++ looks like C? Why does syntax of C look like? Well, there's a reason for it. And the reason, one of the reasons is that it really takes a long time for people to adopt to new ideas and new technologies and to new ideas as well. Changes come in increments. So a beautiful quote by George Santayana, he says, those who cannot remember the past are condemned to repeat it. And so we need to really think about the past before we can think about the future. So programmers don't adapt too well, and this is just my observation looking at a vast majority of developers. Now there are exceptions. I would say a lot of people in this room are outliers, but a lot of the communities out there, people don't change too fast, unfortunately. And we take changes often in bite sizes. And why do really we take so long to really make changes? And how habits really are really hard to change, and it almost takes a new generation. And this got me thinking, and this is not a bad thing, I think this is actually a good thing, but this got me thinking. I was in a conference a few years ago, and I had just given a keynote, and I was, after finishing the keynote, I got down, I sat in a chair, and next to me was this lady, and she quickly introduced herself, and she said she has finished a master's program at the university, she's been working for 2 years. And of course, if somebody says they have finished a master's program and has been working for 2 years, you can do the math very quickly and know how old she is. So that's pretty easy to find out. And then she said, can I ask you a personal question? I said, no, lady, we don't do personal questions, but thanks for coming to the conference. I'm glad you enjoyed it. We're done. And she said, no, please, I really need to ask you this one question. Just one question, allow me to ask you. I said, that's fine, what's your question? And she said, what year did you graduate from college? I said, no, we don't do this. I'm not going to tell you that. She said, no, please, I really need to know what year did you graduate from college? And I told her what year I graduated from college, and her face just brightened up into a big smile, and she said, really? That's the year I was born. And I just stared at her for a few minutes, and I said, could you do me a favor? And she said, what can you help you with? And I said, could you please reach over the cane for me? I need some help to walk around. And all of a sudden, I felt so old sitting next to somebody who is a colleague in the industry who was born after I graduated from college. That evening, I started thinking about it, and I was so excited about this because here I am able to work shoulder to shoulder, so to speak, with somebody who is maybe 1, if not 2 generations younger than me, and that is just amazing in my opinion. Because there are constraints that I place myself in that they're not placing themselves in, like my own children. One of the things I love about watching them is the way they fearlessly ask the question, but why? And they are constantly challenging the ways I do things and say, oh, Daddy, we don't need to do it that way. And then they tell me there are better ways to do. And that evening, I realized this is amazing because in 10 years and to 15 years from now, and every 15 years or so, you have a new generation of programmers who come along and say, but why do you guys do this? Why can't we do it this way? And they shake everything around them and they disrupt the world, and hopefully they make it for better. And I got thinking at that point, how amazing this is, that as time goes on, I am somewhat heading towards my sunset. I'm way past 50 years now, and I'm pretty happy with it. There are things I've learned over the time, but I'm absolutely excited for the young generation of people who are coming and questioning. Hopefully they learn from the mistakes that we have made in the past, but they can tell us there are better ways to do things. And it got me thinking how amazing this is, that there are generations that fade away and generations that come to life and challenge and change the status quo. And it got me thinking how amazing this is, that the universe, the nature is built with automatic garbage collector. This is just amazing to me, in my opinion, that there are things that can change over time naturally, and that to me is very empowering. So we are poised for a very big change moving forward, the next big changes we can look at. And this actually started back in about 2003 to 2006 timeframe. There are two fundamental things that changed around us. The first thing that changed around us was how the hardware technology around us has changed so substantially. We have come to realize that we cannot really pack more into a single processor. Imagine the day when the engineer went up to his boss and said, I couldn't put more into this. It just started melting because we couldn't just manage the heat in it. And multi-core processors are the way of the future. It's really incredible that even small devices today are multiple cores in it. And the second kind of change that happened around us is the business environment itself around us. Companies are dealing with big data and high volume data, and they're expecting much greater demands on applications that they can provide for their own users. And so on one end, the hardware that we rely upon has changed. On the other end is the business demands have changed, and we are stuck right in the middle with the software we are building, and how can we really deliver both the demands of the business and the capabilities of the hardware at the same time. Well, things like the modern demands like cloud computing, big data, microservices, IoT, machine learning algorithms, and on the same token, some technologies to answer them like NoSQL or MapReduce and reactive programming and so on. We've been struggling to really meet these demands on both ends. But if you really think about it, there are some things that are so fundamental, yet fundamentally wrong in my opinion, that we do. One of them is the way we build web technologies. Now, don't get me wrong, I'm not here to tell you that we shouldn't do any of these. We still have to, but we have to question what we do. And how do we really build the web technology today? Well, the technology that we are building today, for most part, is a stateless request response protocol. Now, what does that really feel like in terms of how we build these applications? Here's the way I want to think about it. Imagine I saw you yesterday evening as you were walking out, and I asked you where you're going, and you said, oh, I'm going to go catch this movie. And maybe I see you this morning, and I ask you, hey, did you go to that movie? And you say, yes. Now, how would you expect this conversation not to go? I'll tell you how this conversation goes if we're building the web services of today. So I ask you, did you go to the movie yesterday? You say, oh, yes, I did. How was it? How was what? I mean, that's what you would do, isn't it? Because the way the technology is built right now is, a crudest analogy I can give you is the web applications today are like Dory in Finding Nemo. Because every few minutes, hey, I'm Dory, how you doing? And we completely forget all the state, and this is not the way to build applications. So where do I want to see the future? Well, the future I want to see is based upon a context we can carry around, a conversational state. And the new state is, new way of development, I'm totally convinced about it, is going to be based on continuations. I am absolutely thrilled about continuations, and to be fair though, continuations is not new at all. It's been around for a very long time, and yet this is something most of us have not been able to really use in the mainstream. And if you really ask me, this is one of the things that excites me is every single technology you hear about. Stephen talked about a lot of good, interesting things, but almost every single one of the things you talk about has been around for a very long time, and yet we haven't been able to really benefit from them. Part of the reason for that is, I remember as a young programmer reading about a lot of these ideas, and I would stare through the window and say, wow, this sounds so amazing. I wish I could actually do it. So if you ask me, what are we living today? We're not living the time of new technology. We're living the time of democratization of new technology. And I'm absolutely thrilled about it. Because as a child, I could read about these technologies, but I could not get my hands on it unless I worked in a large university or worked in an esoteric organization. But today, my children can access every one of these for just a few cents at the best. And to me, that is absolutely phenomenal because we are able to afford these technologies. If you think about, serverless technology, if you think about function as a service, now those of you who are maybe as old as I am or older than me will remember you could not have survived the 1980s without hearing the words data flow computing. And if you ever were in the 1980s, and if you walked the mall or sat in a restaurant, you will hear people in the next table chanting data flow, data flow. Like today, you hear them chant Angular and React. And this is the way the world was. And then you kind of wonder, what happened to data flow computing? Well, people didn't talk about it a whole lot. People were trying to build Manchester machines that gave you data flow computing back in the 80s. And then it kind of quieted down. And then suddenly, in the past about 5 to 10 years, people talk about reactive programming and the serverless programmings. If I tell you I've got a great news for you, you can do data flow computing today, you're going to say, Grandpa, sit down, that's not exciting for me. What if I tell you you can do Amazon Lambda today? You're like, oh my gosh, this is the best thing ever. What I told you was you can do data flow computing, right? And this is the beauty of our field. We'll give a new name for what we already do and get totally excited about it. And this time around, it's data flow computing, and similarly, continuations has been around for a good 30 to 40 years, and yet the democratization of this is finally coming. So what is continuations? I'm absolutely excited for continuations because continuation is a data structure that can remember the state of your call. And so the next time you go back to the call, you can have a conversational state with it. Like, for example, did you go to the movie yesterday? Yes, I did. How was it? Oh, it was amazing. We are able to continue our conversation with each other. How would that feel like? Let me give you an example here in JavaScript. I know that is scary, but I think we can learn good things from almost every part of the world and every language, but let's look at this for an example. So I'm going to say for constant, let's say, value, let's call it E, of, let's say, some function foo, for lack of better words. And I'm going to simply output over here, let's say in the loop, I'm going to say, and then with, and I'm going to just print out the value, the element that we have. But what in the world is this little function I'm going to create, which is called foo? I'm going to simply say, here is a function called foo, and within this function, all I'm going to do is simply say entering, that's all I'm going to do. And with this saying entering, what do I want to return from this? I'm going to simply yield a value of 1. Notice it says entering, and it says in the loop with 1. But then I'm going to say over here, let's call it as step 2, and I'm going to yield over here 2. And then I'm going to say over here, let's call it step 3, if you will. And then I'm going to simply output right here, I'll say yield 3. So if you look at this code, let me minimize this a little bit so we can see a little bit more of this. And when I run this code, you can see how we have a conversational state in this code. So I jumped into the function foo. On line number 3, I yielded a result. But then I went back to line number 5 to continue the conversation. I didn't re-enter the function in the top. Now, let's conceptualize this idea a little bit. One of the things we know today compared to 2014 in Java is the concept of Lambda expressions. So what is a Lambda? We know a Lambda is a pure function, an anonymous function. But there's a difference between a Lambda and a closure. So what is a closure? A closure is a Lambda plus, I'm going to use the word immutable to emphasize it, a state. So a closure is a Lambda along with an immutable state that you can carry. Now conceptualize that idea a little bit in your mind. If you enter this function foo, right over here, you can return a tuple. And the tuple that you return can contain 2 parts. One is the result 1, and the remaining part of the tuple could be that body of code captured as a Lambda. After all, Lambda is a function, an anonymous function. What if I can grab this highlighted piece of code and capture it as a Lambda? Then I can return to you a tuple which contains a part of a result and a function you can call back into. When you call back into that function, I can now resume the call right in here, in which turn I would return another tuple with the result of 2 and yet another closure which can capture the state moving forward. And all of a sudden, that idea of returning a tuple with the data and a closure becomes very powerful. What if I can take that concept and roll that into a data structure? That data structure is called continuations. Now, what I showed you here is in JavaScript, but let's switch gears here to Java for just a minute. And I'm absolutely thrilled for where Java is going in this regard. So what I'm going to do here is to say over here, scope is equal to, and I'm going to create a new continuation scope, and I'm going to simply specify scope here as the name for it just for a minute. Now, this code here that I'm writing is in Java, as you can see. Then I'm going to say over here, continuation is equal to new continuation, and I'm going to specify the scope into it, but I'm also going to provide a little lambda. I'll call it do work for a minute. Now, what does the do work method actually do? Let's go ahead and write that right here. So I'm going to say in this case, do work is a method which is taking a continuation scope as a parameter, and I'll just simply say scope here for just a minute. But I'm going to go ahead and say this is going to be a static, if you will, and I'm going to then say import static, let's say java.lang.continuation. And then, of course, within this function, I'm going to simply output entering for now. Let's get down to this and say while, let's say continuation.is done, or at least it's not done, let's go ahead and say. So in this case, I'm going to put a little negation around it, and then I'm going to output, let's say, in the loop. So I'm writing the code just like in the case of Java, I'm writing the code right here in the case of Java using continuations. So in the loop, I'm getting into this particular code, but I'm going to then say continuation.run and ask the continuation to execute moving a little forward. So what does this really provide for us in terms of the capability of this particular code? Let's pass the scope here to get that working. So when I run this code, you can see it says in the loop entering. But let's do what we did in JavaScript a minute ago. So I'm going to say over here yield and pass the scope to it. And then, of course, I'm going to say, let's call this as step 2, if you will. And then I'm going to yield again with the scope one more time in here. And all of a sudden, we have a Java code that can deal with continuations as well. This, of course, is Project Loom that is coming ahead within the next about, I don't know, maybe 2 to 3 to 5 years in the case of Java. So I'm using the Project Loom version of Java here. This is not production ready yet, but this is exciting me because all of a sudden we are able to implement some of these ideas moving forward in Java. And if you ask me to bet my words on one thing, I will tell you this today, is I'm betting on Java being one of the most vibrant languages for doing asynchronous programming in the future. So don't get me wrong, I love parallel programming. My dissertation was related to parallel computing, but I'm going to bet my future on asynchronous programming more than parallelism because with the technology and the world we are moving into with cloud computing and microservices, asynchrony, non-blocking calls is more important than parallelism in my opinion. And while there are ways to do that in Java, it's not really effective in my opinion. And moving forward, I think continuations and fibers are going to make a huge difference. So what is fibers? Fibers is a technology that allows us to have lightweight threads. You can create maybe about a few thousand threads in your application. But to me, threads are fundamentally a flawed way of doing things. Because what do threads do? Threads, unfortunately, are still blocking. And what do you do to get around that problem? You create more threads, so those threads can end up blocking. That is really not a way to scale if you really think about it. And as a result, we are scaling horizontally by creating more and more servers, and the only thing that it does is makes the server deployment much worse and complicated, and it doesn't solve our real problems. Fibers, on the other hand, are truly non-blocking threads. And fibers, you can literally create millions of fibers in an application compared to only a few thousand threads in an application. And I think we're heading in the right direction for that particular reason. But having said that, I'm betting my future on the Project Loom and the fibers and continuations. But this is something that can save the state and resume at the point of execution in the future, and this becomes a really interesting way to start building applications, and we are going to see a fundamental change in the way we are going to build applications in the future. So when it comes to programming languages, I would argue languages should make things, simple things simpler, and they should make really hard things more manageable. And I want this to be the case where we can reduce complexity and not introduce accidental complexity by the languages and solutions we end up using. So let's think about that for a minute. Languages must promote a higher level of abstraction, and they should be composable, and they should really provide declarative style. Now, what I'm really excited about is that Java is moving in this direction. Maybe not at the pace at which a lot of us want, but it is definitely accelerating the pace. And I'm going to show you a few things today in other languages, but I'm excited to tell you that this is something you can do in Java maybe within the next 5 years or so, almost all of what I'm going to show you here today. One of them is I want languages to be absolutely expressive. Now, if you really think about what does a programming language do for me? To me, programming is a series of mini experiments. It's a series of light bulb moments. I come up with ideas and say, oh my gosh, we could do this. And when you have that kind of inspiration, you want the language to make it possible for you to write the code right away. If a language is very ceremonious, it sucks the life out of you. And then you say, never mind, I had a great idea, but I would rather not try it now because it's so hard to do. Now, let's think about expressiveness. How can languages become really expressive? Let's look at one example here. I'm going to say names is equal to, this is JavaScript again, I'm going to say Jack and Jill for a minute. But I want to iterate over these names and print the values. How would I do this? Well, you could do a I equal to 0, I less than, but that is so boring and annoying. What if we can do constant name of names right in here? And then we can simply output the name right off the bat. That becomes a lot easier to work with. Now, similarly, of course, what if I want the index value along the side of what I'm trying to print? This is where the concepts of destructuring is something absolutely phenomenal. So we know structuring is creating an object. Destructuring is the opposite of it. You tear up an object into pieces and extract properties from it. So I'm going to say I comma name, where I'm going to get the index of it and the name as well. And I'm going to say entries over here. And I'm going to now start pulling out of this a couple of different values. For example, I'm going to say this is the index I that I'm interested in and the name that I'm going to be pulling it out of it. So this becomes extremely concise in terms of how you can express the code. So a lot low ceremony and a high fidelity of your code can get you moving towards concepts very quickly. What if languages can move in this direction where, as a programmer, you spend a lot less effort writing code and more time and effort focusing on your domain and problem you're trying to solve? That becomes incredibly powerful. And I want to really have capabilities like this in languages. For example, this is a piece of code in Kotlin, and I'm executing this code, as you can see right in here, and it tells me that I'm able to design a pizza class. But look at the last line of code right in here, the line number 10 that you see at the bottom. Well, there is no semicolons, there are no dots, there are no parentheses, and I can write the code more fluently, like ability to create DSLs or domain-specific languages, and that becomes a charm to design these kinds of API in our code. Imagine a static type language that can give us the capabilities to write fluent code that is expressive. That is all something better for us to write code. So languages can move us in that kind of direction pretty nicely as we work through it. So given this, of course, I want languages to be very expressive. And of course, Java is moving in that direction, even though a lot of times we associate Java with a lot verbosity and ceremony. The designers of Java are definitely heading in that direction. And they're learning constantly from other languages and experiments and seeing if it's feasible and practical to do it in Java, and then bringing those ideas into it. I also want languages to be highly composable. And to that credit, I would say Java 8 was a big game changer in that regard, because composability is something I absolutely love when it comes to programming languages. Let's look at a couple of examples of composability here in Java for just a minute. So if I were to take a little code, let's say we have a collection of names, if you will. So I'm going to say string list of names is equal to, let's create a list of some values. In this case, we'll simply say some names that I want to create right in here and use it. So given these names, I want to create a collection of names which are of length 4, let's say. How would I actually do this? Well, it turns out that's really easy to do with Java 8. So you can simply say output, and you can say, for example, names.stream. And then, of course, you can say filter given a name. I'm interested in a name of length, in this case, of course, 4. And then you can simply say in here collect. And you can then say you are interested in collecting. So the collectors API has a beautiful function here, which is joining. And you can then join this with using a comma, if you will. And as a result, you can create a beautiful code that composes. But this idea of composability, to me, is one of the most important things when it comes to functional programming. There are two things especially important in functional programming. One is composability, and the other is the lazy evaluation. But from the composability point of view, Java already gives us a few tools like this for us to do. As an example, let's get back here to a slightly different example here. Let's go ahead and bring in a function, if you will. And in this case, I'm going to say function. And this function is going to take an integer, let's say, and then it's going to return an integer. I'll call it inc is equal to, and all I'm going to do is return a value of e plus 1. But I can use this code very effectively to increment a value. So I could do something like, for example, inc.apply and send a value of 5, if you will, and we know 5 plus 1 is 6. On the other hand, I could also create another function, we'll call it doubled, where I'm going to take a value e and double it. And of course, we know we can call the double.apply and pass a value of 5, and we know that 5 times 2 is 10. And so as a result, we can use that function too. But from the point of view of composability, this is something that I want to see more and more fluently in languages. But this is Java 8, of course. I want to take a value, let's say 5, and here's what I want to do. I want to say 5 plus 1, let's say times 2, and I want to take the 5 plus 1, which is a 6, and I want to double the value of 6 to get a 12. How in the world can I do it? Well, we got two separate functions on our hand, but composability is an extremely important feature. So we can say and we can then apply the doubled, and then we can say apply, and then we can pass a value of 5 to it. So this value of 5 is taken, and we add a 1 to it, and then we, of course, combine that with a doubled value, and composability is something we can do very effectively, and I look for composability in every corner I turn. But what I want to do is to do this more naturally, where I can take arbitrary functions and I can start composing functions to create other functions. Why is that important to us? The reason is we are really good at doing object-oriented programming, and we do object decomposition. But we also need to be able to effectively do functional decomposition as well, and we can then create bigger functions using smaller functions, and that leads to a much greater power on our hand in terms of expressive ability in code, and I want to see that a lot more fluently when it comes to language capabilities and how we can benefit from that. In a similar way, I also want to mix some of these ideas together, and Java is definitely heading in that direction. But to illustrate this point, I'm going to show you an example here in Kotlin. I'm going to say process 1, I call process, let's say, in this case, let's say 15. But I also call process with, let's say, hello. So given these three things, the process 1, 15, and hello, I want to write a function. I'll call it process. It takes an input which is of type any right in here. And I'm going to simply go ahead and use pattern matching. I'm a huge fan of pattern matching. Kotlin has a when expression which gives you either a statement or expression. In this case, I'm going to use it as a statement. So I'm going to say when input, and what I can do here is say else, and I'm going to simply print out whatever. So ignore the warning that you're going to see right now, but let's look at the code and the output. It says whatever for all the three of them. But I'm going to say if the value is a 1, I want to simply print out 1 as the result, and look at how very expressive that code is. Similarly, I could say over here in, let's say, 13 to 19, and I can simply print out right in here, I could simply say, let's go ahead and say a teen. So when I run this code, the 15 being passed in is displayed as a teen. Well, this is one of the things that excites me. Pattern matching is something that I admire in languages like Haskell and Erlang and Scala and Kotlin and so on. Well, the good news is in Java, between Java 12 and Java 14, we're going to have some very powerful pattern matching. As a very first step in Java 12, we know that switch is an expression now in Java 12. With switch being an expression, we are able to now start moving in this direction of pattern matching. And when you have a case block, it can have a lambda, which can execute that particular branch of code and exit. And as a result, the code becomes more concise and easier to express as well. Similarly, I could say, here's a string, if you will, and I could say a string. And when I run this code, you can see for the string, it is able to tell us a string. Now, again, combine the expressive nature and composability of the code, this becomes absolutely expressive. But I want the languages to go a little further, and I'm glad that Java is still moving in this direction. As an example, let's entertain this thought for just a minute. Suppose I'm writing code in Java as of today, and I'm going to call a process function. I'm going to pass a 1, I call process, and pass a string hello. But I'm going to go back to this code and say public static void, let's say process, and this becomes an input I'm passing to this code. I'm going to simply output the value given to us, which is 1 and hello. But then I'm going to say if input is an instance of string, let's say, then I'm going to say got a string. So when I run the code for the string, it says got a string. But what I really want to do is the following. I want to say got a string of length, and then I'm going to say over here input.length. Well, quick question, will that code compile? No. What do I need to do to make this compile? I have to beautifully write this code, isn't it? This is one of the most beautiful code. We can frame it on the wall. Now, does anyone know what this is called? Yeah, you call it casting. I call it punishment. Because you have already asked the question, is this a string? And you said yes. And this is again what I said earlier. So when I program in Java, sometimes I ask this question, which is pretty vexing. So when you run this code, of course, it's going to tell you it's of length 5, but what is that? That's ceremony. And I always ask the question, do you work for the compiler, or does the compiler work for you? And this is something I want to keep asking the question. When it comes to this code, the Java compiler says, I want you to do this. And you say, can I go to lunch? And Java says, no lunch for you. Sit down and write that code, isn't it? That's a lot of ceremony. But why? Well, Java is going to do in the future what I'm going to show you here in Kotlin. I can simply say a string of length, and then I'm going to simply say input.length and simply call that function right in there. So when I execute the code, you can see it says a string of length, and it prints out what the length is, which is 5 right here. Now, make no mistake, if I'm here, and if I were to say at this point in the code something along the lines of input.length, the compiler will yell at me and say, what in the world are you trying to do? That is an error, because length is not available on any arbitrary variable, but it is available on the string. But you paid the due already to verify it is of type string. So what if language can become very sensible, where it works with you, along with you, rather than being a hindrance? It increases productivity for us. Now keep in mind, when you look at languages like Python, why do the next generation of programmers I talked about gravitate towards those languages? Part of the reason is low ceremony. And because when the language has low ceremony, they're able to be productive and get things done. You know, I started my career programming in C++. I can do any nonsense in my life now. But that's not the next generation of programmers that are out there. They want elegance, they want expressive code, and the languages have to really meet those demands. And I'm thrilled that even Java is moving in that direction to meet that. You want the language to become efficient as well. And of course, in that regard, we could argue that Java has moved in that direction quite a bit with low ceremony and efficiency. For example, if I were to go to the code I had in the past where I'm iterating through the names collection, I can go from a sequential iteration to a parallel iteration very easily without much effort at all. For example, in this case, what if I were to take the collection of names I had a minute ago, if I can bring that back here, and in this case, of course, I want to, let's try this again, that example has vanished. So let's try this again. In this case, let's say we have a list of string, and I'm going to say names is equal to, let's say list of, and I'm going to bring in some names I want to work with. And given this names, of course, what if I want to iterate over these collection of names, but I want to get the very first name, which is of length 4? Well, you could write code like this. You could say names.stream, and then you could say filter given a name, name dot, let's say, length is equal to 4. And then I'm going to perform a map operation. We'll call it as a transform. So given a name, I'm going to say transform the name. We'll see what transform does in just a minute. And then I'm going to say find first to get the very first element from this collection. Well, given this particular example right in here, I want to simply iterate over the collection of names where a name of length 4, and I want to get the very first one among them. What does the transform method do? Let's go ahead and say in this case, we have a string transform which takes a name as an argument, and it simply returns name.to uppercase, let's say. That's all I'm doing for the transformation. So when I execute this code, what it's going to do in this case is to bring in the name which is of length 4, but convert it to uppercase, but give me only the first one. Well, sure, it gave us Dory, but what about efficiency? What if this collection were very large collection, 1 million values in it? That would be really sad if we process all the 1 million values only to throw away a lot of it and just use the first value. That's not going to be very efficient at all. In fact, I want to emphasize that this is one of the reasons why when designing languages, we can't just focus on expressiveness and ignore the details about the performance. And I'm going to say this in a very grim way. I'm going to say cuteness is not sustainable. So this is one thing that I often tell my wife is that cuteness is not sustainable. You know, when maybe a friend has a newborn baby, my wife is so eager to visit with me, and this is the part she hates. And she would say, oh, how cute. And I will always tell the kid, sorry kid, this is not going to last too long. So for humans, cuteness lasts 2 years in their life. Because the end of 2 years, we'd say, terrible to you, you talk too much, be quiet now. So this is exactly the same thing with code as well. A cute code is not sustainable, we still want performance. Well, here's the good news about it, that in the case of this particular code, we have not only the cuteness, let's say called for, and I'm going to say name, but when I run this code, you can see it only called for Dory. It did not call for Gil or Bruce or Nemo. And the reason, of course, is lazy evaluation. So laziness is absolutely necessary when it comes to performance. And performance is very critical because what good is expressive code that does not give performance? And so efficiency is very important. Well, the last thing I want to emphasize here is that I want languages to be almost seamless. And I want almost seamless asynchrony for Java. Well, here is an example. If you notice this is a Stream API. And one thing I love about Stream API is I started working on Java 8 about 2 years before Java 8 was released. My book was the first book released on Java 8 the day Java 8 was released. But earlier on, 2 years before Java 8 was released, if you had an opportunity to look at Java 8 had methods like filter, map, and reduce all on list and set and so on. And one day I wake up in the morning, download the source code from the version control, and suddenly enough my code I was writing in the book worked. And I was a bit of a panic, like where did the filter and map disappear? Well, that's when I noticed they introduced a new function called stream, and all these methods like filter and map were moved to stream from list and set. Well, this is really a brilliant move in my opinion because there's a big difference between a filter versus maybe other methods on a list and a stream. And that is, these methods like filter and map are called intermediate operations. They give you lazy evaluation. Now imagine when you're writing code, you don't really see this evidently in your eyes. It could be really surprising because it's not about syntax, but the semantical difference that's very important. So in other words, I never want a program to fool the programmer, and a good program reveals the intent very clearly to the reader. And the reason I like this code is the word stream here is alerting the programmer there's a semantical difference here. You are jumping onto a lazy evaluation, be careful. And that kind of semantical difference is very critical. And in fact, this is one of the things I'm hoping that fibers will have, because today, as of today, fibers are absolutely seamless. I'm not thrilled about it. I want fibers to be almost seamless. Let me give you an example of what I mean by almost seamless really quickly here. So I'm going to create a function called task1, and this function is called task 1, and all I'm going to do is print out right in here, let's simply say entering task 1. Well, I'm also going to print out exiting task 1. Just enter in this thought for a minute. I'm going to create one more function right here, task 2, and all I'm going to do is simply say the same thing right here as task 2. But within here, I'm going to bring in, this is Kotlin code, of course, I'm going to bring in Kotlin.coroutines, and we talked about coroutines and continuations a little bit in Java, but Kotlin already has coroutines already, and I'm going to bring in the Kotlin coroutines, and I'm going to simply say here, let's call it as run blocking, and within this, I'm going to call task 1, I'm going to call task 2, but I'm also then going to say started, and that's all I'm going to print out right now. So given this little example, I've written a blocking code, and all it's going to do is to simply call task 1 and task 2. Nothing surprising. This is exactly what we would expect of this code. However, what I can then do is to go back to this code, and I can say launch over here, and I can ask it to dispatch these two calls asynchronously. So now, of course, when I run the code, started is appearing in the top rather than in the bottom, as you can see. But we can take this a little bit further. I want you to pay attention to the first part here. You entered task 1, you finished task 1, then you entered task 2 and finished task 2. But imagine task 1 and task 2 are performing an I/O operation, like calling a web service or a microservice. You want these calls to be non-blocking. How do I make this call non-blocking? Languages can make life really easy to make the calls non-blocking. So what I can do is I can simply say yield over here, and I can also do yield over here. Now all of a sudden, you are turning this call from a synchronous blocking call to a non-synchronous, a synchronous blocking call to a asynchronous non-blocking call. However, remember, one of the things I want to emphasize is almost seamless. I want the structure of the code to be exactly the same, but not so same that you don't realize you are crossing a semantical boundary. So in that regard, I think Kotlin has done the right step in this case to just give us a little clue. Now, to be fair though, I love what Kotlin is and I love the language, but I do have one formal complaint to make. Well, these are amazing language. They define this as fun because they want us to have fun every time we write code. But they should have thought about it a little bit more. Now they say suspend fun. How cruel that is. But this is the way you say that this is a suspendable function that you are trying to create. Now the benefit of this particular code here is you are marking this method as a suspendable method. What is the benefit of just making that so small a subtle change that you saw here? Well, the beauty of that is notice how we entered both task 1 and task 2, and now we put those two tasks in pending, and then when we finish the task, we can come back and resume it. So automatically these code became non-blocking, and that is absolutely powerful. Well, the good news is you will be able to do this very soon with continuations and fibers. Like, the only complaint I have is they make it almost seamless, not entirely seamless. Right now fibers are very seamless, but there's a semantical difference. I would like to see that semantic difference in the eyes of a programmer so they don't get surprised by a different execution in the code. So I want languages to make the structure so similar so we can gain on efficiency, but at the same time it's almost seamless, not entirely seamless in that regard. So how can we prepare for the future of programming in languages like Java? Well, here's the beauty of it. I like to learn different programming languages, not just because I want to go start programming in those languages, but it's because when I come back to programming the language I program in, I can be a lot better in programming those languages. This reminds me of one particular story I heard about, which I think is pretty amazing when you think about it. This was a story I heard on NPR about a research study in Chicago. What they did was they took very small children, all the way from toddlers to just a few years of age. And remember, these are innocent children. And they took these children and they did an experiment with these children. So what this person doing the research did is they put the child, like for example, let's say I'm the researcher, and let's say the child is sitting where you are sitting, and they would ask the question to the children, how many apples do you see, or how many banana you see? Now, there were two groups of children they did in this experiment. The first group of children were children who were exposed to only one natural language. Their parents spoke a language, the people in the school spoke the same language, their nanny spoke the same language, so the children were exposed to only one language. The second group of children were children whose parents spoke one language, but children in the school spoke a different language, or their nanny spoke a different language. So these children were not speaking multiple languages, but they were exposed to people who were speaking multiple languages on a daily basis. And they went to these children, and the researcher would ask the question, how many banana you see or how many apple you see? But what they did was they would have a fruit over here. Between the child and the person asking the question, they would also have these objects behind the person asking the question. And they found something absolutely consistent, which is mind-blowing. For every single time this question was asked, the children who were exposed to only one language would always include all the fruits they could see. On the other hand, the children who were exposed to multiple languages, when the question was asked, they would immediately look at the person asking the question and realize, well, obviously this person can see the fruit between the two, but will not be able to see the fruit behind them, and they would subtract those, and rather than saying 3, they would always say 1, for example. And this was consistent among the children, and so their analysis was, when the children were exposed to multiple languages, the children were thinking through the eyes of the person asking the question. In turn, it means there's empathy, and you are able to visualize it from the other people's point of view. Now, of course, I'm not a language specialist, as a natural language specialist, but I can vouch for you. Learning multiple different languages has definitely done that for me, because when I look at multiple languages, I look at the language I program in predominantly very differently. I look at the way to design with it very differently, and I also expect a lot different things from the language as well moving forward. So the amount of time we need to learn a new concept is inversely proportional to the number of diverse ideas we've been exposed to. And that diversity of idea to me is absolutely critical. And I teach courses in the industry. I work with developers, and often I find the developers who are very quick in learning ideas are the developers who have been exposed to multiple very different languages than those that have not really been exposed to. And I'm going to say learning different languages is something I do not for using all of them, but because I'm able to adapt to the changes very quickly, and I'm able to learn the changes in the language I predominantly use as the language itself evolves. And to me, that is absolutely central, because the time that is essence in my opinion. If I can learn these languages very quickly and adopt, that is benefit to the business I work with, and the one way I can accelerate that learning is by diversifying the language. So to summarize what I talked about, I want to say, don't wait for the future. It is already here today. And one of the ways we can prepare for the future is by diversifying on the languages in the JVM. And as a result, when Java matures to accommodate some of these features, you're already there, and all you have to do is just learn the syntactical difference, because semantically you're already aligned with it using some of these languages. Hope that was useful. Thank you.
Greatness. What does it do? It hogs the limelight, chases fame and adoration, does it for the prizes, followers, the fans. It gets on the guest list. It gets in the headlines. It says, look at me. But it doesn't have to. There's a different kind of greatness.
That is selfless in its endeavors. That shares what it knows. One that sees patterns, the form, the key, and is constantly learning.
Greatness is tabs or spaces.
No, 4 spaces.
Greatness is algorithms, seeing past boundaries.
Working on a global scale.
This greatness asks,
it doesn't work. Why doesn't it work? It works. Why does it work?
This greatness finds the answer, shares it without pomp or ceremony, and moves on to the next challenge.
Yeah, I work. But when I get home, I go to work.
Why? Because this greatness is forever curious. So here's to those.
To the digital pioneers, the quiet conquerors, the coders, who bring the future that little bit closer to us all.
Here's to those who've been there,
done that, got the t-shirt,
and grown out of it.
Here's to a life in code. Here's to the new face of greatness.
Okay, so you guys were able to see some of the groundbreakers who we brought on to do the video shoot. And what we did as a special event for this conference is we did an online award for the groundbreakers where we let the community both nominate and vote for the folks who are going to receive the award. So this was done entirely in the open. You probably saw some of the Twitter traffic for groundbreakers for both the nominations and the folks who are going to receive the award. All 4 of the folks who were the top winners in terms of the number of folks who recognized them on social media, we invited to come fly out here to Oracle Code New York, and we're going to present them with some awards today, and we're also going to do a panel with them. So I think this is really exciting that we're able to recognize some folks from the community who are doing great work with open source, with diversity and women in technology, with education and teaching people about the next generation of technologies. So please join me in both celebrating and recognizing some of these folks who are advancing our development community, and also think of some questions that you guys want to ask them. So we'll have a short Q&A towards the end of the panel as well, where you guys get to ask some questions to the folks. Okay, we also have some really nice awards as well for folks who we're going to invite up on stage. So the first person I'd like to invite up is Karla De Bona. She's the founder of Reprogramma, a UI and UX designer. Please come up, Karla. Okay, so thank you very much.
Thank you so much.
You deserve it.
Yes.
And just wait here for a sec and then pose for the folks in the audience to get a quick photo shot. All right, big round of applause for Karla. Okay, if you wouldn't mind, yeah, feel free to take a seat. Okay, so the next person I'd like to invite up is somebody who you guys are intimately familiar with, a great developer, and also an inspiration for all of us when it comes to our daily lives of coding. Venkat, thank you very much.
Thank you very much. Thank you.
Okay, if you wouldn't mind, stand here for a sec for photos. Okay, thank you. So the third person I'd like to recognize is Nebras Lamouche. He's a technical leader, an author, and a speaker, and he writes lots of great content, which you've probably seen online. Nebras, please join me. So it's an honor. Thank you very much.
Thank you. Thank you.
All right. Oh, sorry, we're holding it the wrong way. Thank you. Okay, and please stand for some photos. Okay, thank you. All right, and last but not least, I'd like to invite Raphael Winterhalter up on stage. So Raphael is the founder of ByteBuddy, a great contributor to the open source community, and a great friend. Come on, closer. All right, thank you very much. Thanks. All right, and please stand here for a sec for photos. Don't cover the words. There you go. Okay, thank you. Please have a seat. Okay, so what we're going to do is we're going to have a casual conversation with these really great people to talk about some of the things which you guys are passionate about. Here's a microphone for you. You already have your microphone? Okay, excellent. And so we were chatting earlier a bit, kind of about what excites you guys about what you do, but what do you find is your passion? What gives you the drive to continue building content, to engaging with developers online? Kind of where do you find your drive from? Anyone want to start?
I think my passion is help someone to enter in the technology area. Because of that, I'm a co-founder of Reprograma, because I intend that the future is in technology, and because of that, I have to insert women in the technology area.
So one of the things that excites me is, we often build applications, but then we rebuild it, and we, over time, as we add features, we try to reduce complexity. To me, that's exactly what we do in our learning process as well, because a lot of things are very complex when we get to know about them. What excites me a lot is when I'm able to understand it a little bit better, and I get excited about sharing that understanding, so the journey for somebody else is much more pleasant in terms of simplifying the ideas. So that's what I like doing, is to learn and then share that to simplify the ideas for other people.
And I think we were chatting about sharing Nebraska. Yeah. So,
for me, I had some difficulties when I started working, especially with getting started with a job. So what boosts me actually to do is sharing knowledge with new people, with newbies, students, and how they can start easier their career. So as I said, sharing is caring. So when we share knowledge, we take care of newbies and let them start smoothly.
You want to?
Yeah, sure. I mean, from the outside, programming always looks like you're just sitting in front of a computer and you're doing the same thing over and over again. But in reality, programming is such an exciting profession, and you get to work with people, you get to teach people the things you know, you get to learn new things from these very same people that you teach things to, and you get to reinvent your job every day, basically, and that's what's exciting about this profession.
Cool. And so I really like that, in your presentation, Venkat, you were chatting a lot about the next generation, like the younger generation of developers, who we all get to interact with and help and mentor to become the future of our industry. So can you guys think of any examples where you've felt like you've really been able to make a difference in people's lives?
I mean, from my perspective, you probably don't see it as much if you teach people, but if I just think back of, I'm not being in software that long, but the first people that picked me up on my first project, and you get to basically learn everything for the first time, it's really important that someone helps you through this process. And doing the very same thing for people now, and that you can mentor someone to walk through that. That's just also a great experience for everybody involved.
In Reprograma, we worked with, in general, employed women, and then women that know something, doing some graduate, but wants to work with technology, but for some reason, they don't have opportunity yet. Then we invited these girls to learn how to code in 18 weeks. And then we have an event called the Speed Hiring, and these women got a job. And for me, this is a big transformation because I see women a new opportunity to her life.
So one of the things that I hear people say often is, how advanced the industry is and the demands of the industry is in terms of programmers, but how universities are often not prepared to really deliver that. And often I tell the people, well, great, now you have a problem you've identified, but it's important that you go solve it. So one of the things I always encourage people is to spend some time to go back and teach at the schools, at the universities. And of course, what good is telling others should do if I'm not willing to do it myself? And that's one of the things I realized over years ago, is that as much as I work in the industry, I still continue to teach at the university. And part of the reason I do that is if you can catch those young developers early on, and not just get them excited about technology, but one of the things that is so important in our industry is not just the knowledge, but also the discipline. How do we create quality code that becomes maintainable? And I would say that's one of the things that I've been passionate about, is to teach them to develop not just code, to not just learn technology, but also to kind of, come to this sustainable speed where they can create maintainable application as well. And that's what I would encourage other people to do, is to spend some time with these young developers to teach them things you have taken time to learn over the years. Maybe you can inspire them to learn that in a better way.
I can join the idea of Venkat. Recently, I did some subject for a school, an engineering school in Tunisia. So we got a subject called software architecture. So as it was old software, we're talking about SOAP, talking about old architecture. So what we did, we tried with the collaboration with the university to do microservices and cloud-native architecture instead of giving old SOAP content for students. So in November, we gave the subject for 50 students about microservices, Docker, Kubernetes, OpenShift, how to deal with cloud-native architecture. And hopefully what we are seeing now for the students, that they are all working in trendy technologies, making new content, up-to-date content, not spending so much time to start, because we helped them starting fast, so they are producing more and they are up-to-date with the market. For me, I remember when I got graduated, I was so far from the upstream. I know EGB2. I don't know if people has done EGB2. So when the market was on EGB3, so I was really out of date. So this is the idea.
Yeah, so I think any of you would probably compare. So I remember when I was taking my programming courses in college, if I had Dr. Venkat teaching me functional programming, I think I would have turned out very differently. So that's awesome. So I think you guys are all involved in technology and user interfaces and kind of building the next generation of applications. So where do you guys see technology going? Like if you were to give people advice on these are the things which really matter that they should focus their attention on, like what would it be? Is it going to be fibers? Is that the next big thing, Venkat? What's the future?
I think definitely asynchrony is something I would emphasize. In a way, if you really think about it, JavaScript got it right in the early on time, even though conceptually not implementation-wise. I think this is where Java can make a huge difference in terms of getting a really efficient implementation to this idea. So certainly asynchrony is something that I care a lot about, but there are so many other things as well that we need to really focus on. We still, as an industry, struggling to create maintainable code as well. Ask anyone to give an estimate on how much time they're going to take to finish something. That's still dark magic right now. So we can get a little bit better by creating more maintainable code. That's something we can do. But there's yet another thing outside of technology that I think we still are not paying enough attention, which is really the collaboration among developers. I remember, I always say this as a way to express my complaint about the industry. I remember the very first day I got my first job, and I go to my work, and they said, thanks for joining, and they took me to the office, and they said, here's your table, here's your chair, and they locked the room and walked away. And the very first thing I did, I remember clearly, is I dialed my wife and said, what do I do now? I'm sitting here in this room, and they expect me to do stuff, and they're paying me for it. I have no clue what to do. And I would never forget that day, because that was the worst day of my life in a way, professionally. Instead, if I was told, you have no responsibilities whatsoever, you have to just work with an experienced programmer and learn from them, I think we're still far away in that regard in our industry. So as much as technology is important, I think we need to really embrace that act of bringing people on board and onboarding them for smoother transition. We can learn better practices from other people that have taken 10, 15 years to learn it, not by isolating, but by collaborating, I think.
Yeah, I also always tell people to focus on the fundamentals, because that's basically the common ground, also because you have to work in teams. And I mean, I tell young developers especially, it's easy to get distracted, but focus on the things that really matter. Learn SQL, learn the basics of the programming language you're using, because that's going to stick around and you're going to use this again and again, and then it's easier to connect to a code base and share this with people and work together, because in the end, software has become so ubiquitous, and you have to be able to work with other people's code and maintain other people's code. So it's good to have a common ground and not like jump on every new technology out there, and take it easy and take it slow.
Okay, so mentoring, fundamentals. What else? What else do people need to be successful?
I think we have to focus and understand the possibilities, the limits, and the question related with ethics when we think about machine learning, because I'm from user experience, my background is there, and I understand that we have a lot of questions and probably changes when we think about how to create new experience with machine learning and the data that we have.
Yes. Oh, go ahead.
Yeah. For me, I think that the productivity, I think where we are going now, before we never dealt with infrastructure. So now we deal, for example, to prepare containers for the deployment. We are making things, we prepare, for example, some infrastructure in Kubernetes, for example, to do something that we, as developers, didn't that before. So for the future, with the online IDEs like Eclipse J, for example, or the growing of Kubernetes will boost productivity of developers. But the thing that I call for everyone and I ask everyone to do is not to be afraid from buzzwords. As Venkat said, we always like to give new names to the same thing. So always try to break the iceberg to go what means this buzzword. It's by the end, it's a concept that we know already in programming. That's it.
Okay, and I'll kind of ask you guys one last question, then we'll open it up for the audience to ask some questions. But so I think there was a lot of focus on productivity, like how you can use tools to be more efficient, and then you mentioned machine learning. So are the machines going to take over our jobs? Will the next generation of software be created by intelligent robots instead of humans?
Hopefully the boring jobs, they will be taken by the machines. But at least my
okay, so unit testing, right?
Exactly, no, but I mean, actually, there are attempts to automate unit tests, to generate tests by looking at a code base and to at least write the basic tests. And that's a good thing, because people often don't write unit tests because they think it's boring. And if you can automate these repetitive tasks by machine learning, then that's a great improvement. But I don't think we're there yet to, at least in the next decades, to give up on our careers, hopefully.
We already have the crew here, so you guys will be the trainers for the machine learning cluster. Do the reinforcement training. Dr. Venkat will teach the computers how to program better than the rest of us.
Well, one of the things that excites me is what Darwin said. It's not the fittest that survive, but the most adaptable that survives. And to me, that is the most important thing is, if you really think about it, I've been programming for 30 plus years, but the only reason I'm able to survive is because I constantly learn and constantly find better ways to do things. So if you put learning and keeping your mind agile, then it's a question of transforming as we figure out what the future is. And to Raphael's point, absolutely, things that are repetitive, that shouldn't be done by the humans, should be really automated. And then that's going to leave us with things that are still worth the human experience to develop it. And at that point, it's a question of what we can learn and adapt. And if we don't learn and adapt, we're going to perish. So that's going to be the case. That's been the case forever, actually. And this is going to only make it even more important.
And I think we are like a human, we are very creative. And I think we will create new jobs and new functions to do something related with the machines.
All right, cool. So let's open it up for some questions from the audience. So we have some folks with microphones who will run around and bring you a microphone so you can ask your question. But if you have something you want to ask the folks on stage, just raise your hand, and we'll try to get a few folks included in the Q&A session. So anyone want to take the first question? Okay, so we have, we first, Alexa? Go ahead, Alexa.
So this is a question sort of for Nebraska, but maybe for all of you. So you mentioned now programmers are dealing with Kubernetes and setting up infrastructure. Is that better, or at some point do you want that to get automated as well, so you don't have to worry about the deployment piece?
For a good developer, for me, a good developer is a lazy developer. It's a developer who does not spend so much effort to do things. For me, when I started doing microservices by the start, I was doing every stack, doing the service registry, doing the configuration server, doing everything, spending so much time, being tired, going home very tired. So when I met Kubernetes and I saw functionalities and features provided by the orchestrator, I saw that I can delegate everything for the Kubernetes, not doing service registry, eliminating so many components of the application. So spending so much less effort, being so lazy, and doing the same job. So for me, it's easier, it's better, and it's lovely.
I couldn't agree more. Absolutely. One of the things I want to emphasize is, learn how things work and have the wisdom not to do it manually. Learning how things work is very important, because when things don't work, it's not going to be helpful to say, well, it's automated, I have no clue how it works. But we need to really understand how things work, but then have the wisdom to not have to waste the time to do it manually. But we are ready to step in when needed. That's critical.
Okay, and we had a question from the gentleman in the red shirt right here.
Hi there. If there is a 7 or 8-year-old kid standing in front of you asking you, what can I do now so that I will be as cool as you are when I get to your stage, what would you tell him or her? Thank you.
First thing I would say is I'm not cool at all. In fact, one thing I would really tell, it's a really good question, thanks for asking that. And I would say that don't be like me when I was 7 years old. I was a person with learning disabilities. I actually failed in school. It was incredibly hard for me. And what really made the difference for me was to figure out that studying is boring, but learning is fun. And that's what I really took time to figure out. I was a really bad student, but I'm a great learner. And I'm curious. I want to know how things work. And in a way that the education systems and societies are moving us in the wrong direction. And I think we need to inspire that. It's like what Da Vinci said, the mind is not a vessel to be filled, but something to be lit on fire. That's what I would tell the kid is just be yourself and let your curiosity guide you, not the standards we set around as adults around what you need to learn.
I can only speak from my most experience, which is open source. If you find something that you like, you'll just continue doing it, then it's feeling recreational. It's like some people like to play Sudoku, right? And some people like to look into a code base that they created. And
some people like to stare at JVM bytecodes.
Yeah, exactly. Some people do. And I know it sounds a strange hobby, but in the end, it's the same idea. You'd like to keep your mind occupied, and then that's a great activity. And if you just follow what you're currently interested in, don't try to, again, like jump the newest trend or something, just find something that nobody else likes, like Java bytecode manipulation, and dive deep into it. And that's just a fun thing, and you can keep it doing for years and years.
And I think it's a mixing of curiosity, discipline, and focus.
Okay, so the other gentleman in the red shirt, yes?
Thank you. I would like to ask you, Dr. Venkat, about that future for programming. So we have, for example, today, machine learning, autonomous database, and maybe programming learning too in the future, so without human beings. So is it possible in the future that programming, most programming be without people, robots, or intellectual stuff? Thank you.
Okay, so our future algorithms can be designed by machines instead of people. Anyone want to take that?
I don't know. I think we have to understand that we have some limits, and you think about that. But I think the algorithms, you have to understand the possibilities and the limits. I don't know where is this. This is my question. That's when I fuck my study at this moment, because I understand that sometimes with algorithm we can use the anticipatory design, but sometimes we are take off the choose. Then what's right? What's wrong? I don't know yet.
I think it's going to be a combination of the two, but one thing that fascinates me in today's world is just the explosion of data that we have in front of us. And the sheer volume of data, it's impossible for humans to really do anything meaningful with it. So we definitely need machines to comprehend that and analyze it. But at the same time, though, there is one problem with algorithms to let them loose, which is the things we've been hearing about in terms of the biases these algorithms have as well. And so I think that's where the human intervention is still necessary to apply the context to the results. And without the context, data in, data out, garbage in, garbage out. So I think it's going to be a combination of things that is going to make it more effective. On one hand, we need the power of tools to manage the complexity and the magnitude. On the other hand, we need still the human beings to make sure that that outcome is still relevant and can help us move in the right direction.
Okay. And I think we have time for 2 more questions. So this gentleman in the front, please go ahead.
Yeah, thank you, Venkat, for the amazing session in the morning. My question is related to the composability, which you explained. How testability is important with composability? That's my first question. And the second one is, are the testing frameworks evolved enough to meet the future needs of programming? Or how you see the test-driven development blended with the functional programming?
Thank you. That's a really good question. So one of the things about composability is, you're absolutely right. It does seem overwhelming. But one of the key things about composability is learning the semantics of things. Let's step back for a second and talk about something we are absolutely familiar with. If I ask you, is it really hard to test Java code? You're probably going to say, no, it's not really. Just step through the debugger. And if I say, I'm glad you say it because I got 1,000 threads running, you're going to say, get out of here. Because the problem with threads is the non-deterministic nature of the threads. If somebody wants to test a code which is multi-threaded, the first thing you would ask them to do is to understand how the semantics of the threading works. It's the same exact thing with composability. Composability goes hand in hand with the laziness as well. If we understand the semantics of it, it becomes a lot easier to test it. That's the first thing. The second thing is, composability should not compromise cohesion. And to me, a cohesive code is a code that's very narrow, focused, and does one thing well. And by able to make the code cohesive, we are able to make it much more easy to compose. In that regard, the cohesive parts that compose together can be tested in isolation. This is one of the beautiful things about generally functional programming is that functions are pure functions. And ironically, when a function is pure, it's easier to test. So it actually goes hand in hand with that as well. So in all fairness, it's easier to test as long as we understand the semantics of it. And of course, there's no compromise for it. But it's a good point about testing tools. One of the challenges with testing tools is because of the laziness of the evaluation, there are times when your execution final endpoint may be within a Lambda, for example. Then your testing tools have to be capable to know that your task is not completed when the main code is initialized, but when the Lambda executes. And it depends on the language and the tools. In the terms of JavaScript, the tools are a little bit better. In the case of Java, we're still seeing development happening in this regard. This also changes with languages as well. In fact, this complexity only becomes even worse because now not only we have composability, we also have asynchrony using coroutines. And how do you really test those things? This again is where there are some tools that are favoring better testability, but the learning curve is pretty steep. So we do have to take some time to learn the right ways to do. So your point well taken, we definitely need some improvements in that area.
Okay, very good. And last question, the gentleman in the white shirt.
Hi, Venkat. How long do you think Java can sustain in this industry?
So a few years ago, back in 2006, 2007 timeframe, I will admit I was one of those guys on the other side of the picket line constantly complaining that Java sucks. For me to really speak proudly of Java, it deserves every bit of the merit. And to me, the game changer for that was Java 8. And suddenly I saw Java running on the lawn, happy and healthy. And one of the key things to keep in mind is we tend to forget this along the way. Java as a language is not being developed by the same people anymore. It's a very different generation of programmers who are designing Java. And knowing who those people are, I have to tell you that I'm absolutely thrilled to see where the language is going. I'm not suggesting by any means that people who did in the past were no good. They were phenomenal. But it's a different generation of people who are maintaining the language. The language has been around for 20 plus years, close to that now. And as a result, it's a different set of people with a different mindset, different desires moving the language forward. A lot of people were worried about the release cadence of Java, but honestly, I'm absolutely thrilled about it because it removes the impediments for the language to move faster in a better way. Java is not being developed in a 6-month cycle. Java is being released in a 6-month cycle, which means that developers are able to spend the time to bring in quality, but don't have to wait for 7 years to see that being realized in the industry. So if you ask me how confident I am with Java, I'm going to say that I'm absolutely confident for at least the next 10 years. No language has survived this long. Java is definitely something that's an outlier in this regard. But I'm more confident about Java today than I was 7 years ago.
Thank you. Thank you.
All right, so a big round of applause for our entire panel. And I appreciate you guys sharing some of your wisdom and knowledge. And you guys will get to see more presentations and content like what Venkat and others have shared on stage. And you can also continue to ask these guys interview questions at the Groundbreaker Award panel area on the right side of the stage from your perspective. So thank you guys very much. So we have a few housekeeping notes before everyone runs off, so just give me 5 more minutes. So quick photo opportunity with folks on stage. Here, move in, chip, chip. All right. Okay, thanks. Okay, so a few notes for the conference as you guys are going around. So we have a few product announcements. Oracle Database 18c is now released, so you can use this for free. Oracle XE is now available for free. You can also test 19c at livesql.oracle.com. So this is the latest version of Oracle Database you can try online right now. A quick note about our new Java 12 release. We talked a bit about Java technology. Donald Smith, who is one of the product managers for Java, is here. So you can find out the latest information directly from the folks who build the technology in Donald's session at 11:30 in Hall E, room 8. You can also check out Java, which is officially part of our Oracle Cloud builds. So Java 8, 11, and 12 are now part of Oracle Linux. You can download them directly off the Yum servers. And we also have a new developer image. So the developer image includes Java, DevOps, different OCI tools, the latest releases of Java, SE 11 and 12, and then SQL Developer. So give that a try. We talked a bit about how to become a groundbreaker. And you can find out more about these technologies and the award recipients at developer.oracle.com, which is our developer portal for all things developer technology related. As you're going around the conference, use the mobile app for navigating. It has the latest information on the sessions. When you sign into the Oracle Events app, click on the plus sign and then choose Oracle Code New York, and that'll add in all the session content for today. So you can see what's going on, including all this content. We're in the keynote now. We have a period in the lounge where you guys can check out some of the Groundbreaker Hub experiences that I talked about. Then we go into developer sessions at 11:30. So those are going to start directly. One session I'd like to highlight for folks that I think is really important is we talked about the next generation of developers, how you can grow your career. We have a great panel for growing your career in a diverse workplace, which is moderated by Rupal Hollenbeck, who is our Senior Vice President of Corporate Marketing, and has a lot of great panelists who have wisdom to share, including Venkat, Ronica, Maria, Jean, and Loyana. So please join us for that panel at 1:10 p.m. in room 9. And finally, as I mentioned earlier, we have an Oracle Cloud offer for everybody. So you can download a $500 trial for Oracle Cloud at this URL. And please give it a try so you can learn the latest in serverless, Kubernetes, and other emerging technologies. So thank you guys very much for joining us for the keynotes, and enjoy the rest of the day here at Oracle Code New York. All right, thanks, guys. I've been traveling around to a bunch of the Oracle Code events worldwide. We've done these across the US, Europe, and now Asia. We just finished Oracle Code Japan, which was an awesome event. We're on a motorcycle tour following that event, traveling across Japan, visiting different user groups. The reason why Oracle's reaching out to developers is the way people buy software, services, and products has really changed. Now, developers have a lot more control over the technologies they use, so we want to directly engage with developers, teach them about some new open source technologies, and then show them that those technologies which we're using run very well on the Oracle Cloud. One of the big advantages Oracle has is having a very large community. So by building on top of our stack, you're not only getting the Oracle products and services which run on our cloud technology, but you're also getting a lot of community support from folks in those open source technology communities. So there's over 300 Java user groups globally, Java user groups and the Oracle user groups. They run their own events, they talk about technologies, they help folks get up to speed on how they can use our cloud technologies and platforms, and you can be part of the community. Basically, we're traveling across Japan and stopping at a dozen user groups in between via motorcycle. So it's a very efficient way to hit up a bunch of different communities throughout Japan. So in the big cities, you get large numbers of developers because there's large consulting companies, a lot of software development happening there. But in the smaller areas of Japan, you get a very local flavor to the communities and the user groups. And there's large user group communities, but they don't always get the attention and the visibility which they would get normally if they were in a large hub.